The atom, a seemingly unlikely source of immense power invisible to the naked eye, capable of releasing amounts of energy unmatched by chemical reactions. But how can we release this energy? Where does this energy come from? And how have we managed to use it to generate electricity? The main way of releasing nuclear energy here on Earth is fission. Fission is a nuclear reaction where a nucleus splits into two or more nuclei. To trigger fission, atoms that are capable of fissioning are bombarded with subatomic particles such as protons and neutrons. The most illustrated example of this is the bombardment of uranium-235 with a neutron. If U-235 absorbs the neutron, it will become the highly unstable compound nucleus uranium-236. Most of the time, this compound nucleus will fission, yielding barium-141, krypton-92, 3 neutrons, and the previously mentioned huge amounts of energy. The nucleus of an atom consists of positively charged protons and neutrally charged neutrons, collectively known as nucleons. The protons repel each other just like magnets, due to the electrostatic force acting on them. So how can protons be so tightly packed together in a nucleus? There's another force acting on the protons and neutrons called the strong nuclear force. This force is much stronger than the electrostatic force, but only on extremely short distances. The vast majority of atoms are not capable of fissioning as well as uranium or plutonium because they are not large enough. Heavier elements are special in that the strong nuclear force is not capable of holding the nucleons together over very long distances. A little excitation energy from a neutron can lead to these heavy elements reaching their thresholds for fission. The energy released during fission is vastly kinetic, as the nucleons overcome the strong nuclear force and therefore are repelled by the electrostatic force. Due to the mass and energy being equivalent, we can use Einstein's E=mc² formula to calculate that around 200 mega-electron-volts of energy are released on average in the U-235 fission. There are numerous nuclear reactor designs, so take this simplified nuclear reactor core for example. It consists of a container with water, uranium fuel rods, and control rods. In the core, water absorbs the heat. It can then be used to heat the water in a separate system to generate steam, which powers turbines that produce electricity. Control rods can be used to control the amount of fission or energy generation going on in the core. As you have seen, fission releases a few extra neutrons that can go on to cause other reactions. Control rods are made of materials that absorb neutrons without undergoing nuclear reactions. Thanks for watching, and I hope you found this video interesting.